A curve has the equation y is equals to x cubed plus ax squared minus 7, where a is the constant. The gradient of the curve when x is equals to 4 is twice the gradient of the curve when x is equals to negative 1. Now work out the value of a. See, we have the equation of this curve where a is a constant. The gradient of the curve is, see, to calculate the gradient, to know whether the function is increasing, decreasing, maxima, minima, these are the part of calculus. That means you have to do differentiation. So to calculate the gradient is what? M, and m is also dy over dx. Differentiating this one, because the formula to calculate differentiation is x to the power of n. Differentiation of x to the power of n is n x to the power of n minus 1. This is a formula. So you'll get this one and you have to remember. So when I differentiate dy over dx, x cube will become, on applying the same formula, x to the power of 3. So n is 3. So put it here 3 x to the power of 3 minus 1. So 3x squared. So that's why differentiation of x cube will become 3x squared. This will become 2ax because constant remains there. And the differentiation of any constant is 0. So this is your final differentiation. Now it says the gradient of the curve at x equals 4. That means what will be the gradient at x equals 4? You just need to substitute 4 here. So 3 into 4 squared plus 2a into 4. That means 16 times 3 is 48 plus 8a. This is the differentiation at x equals 4. Now we have to calculate. It says twice the gradient of the curve when x is equals to negative 1. Now try to understand. What we have to do is we have to calculate the gradient which we have calculated by finding the differentiation. Now it says the gradient of the curve at x equals 4. If it says the gradient is at x equals something, that means whatever your gradient function comes out, this is your gradient function. Here you have to put x is equals to 4, and same I did it here. Similarly, I need to put x equals negative 1 because they are talking about gradient at x equals negative 1. So gradient at x is equals to negative 1 will be, putting the value here. So this will be 3 into minus 1 whole squared plus 2a into minus 1. So answer is 3 minus 2a. There is a relationship given between them that gradient of the curve at x equals 4 is twice the gradient at x equals negative 1. So I can say that this gradient 48 plus 8a is twice of the gradient at x equals negative 1. So it's 2 times of 3 minus 2a. So it will be 48 plus 8a, 6 minus 4a. Now bring a to this side and number to this side. This will be 12a and this will be minus 42. A is minus 42 over 12, which then can be simplified as negative 3.5. So final answer is negative 3.5. Prove that 3x plus 5 whole squared minus 5x plus 10 is greater than equal 0 for all values of x. See, don't just equate, like make it greater than 0. They are saying that you have to prove that this is always greater than equal 0. That means I need to take only this expression and I need to prove that this expression is always going to be positive. Doesn't matter what value of x I'll put there, I'll always get it a negative positive answer, and that will definitely make it greater than equals to 0. So here first we need to expand this. So on expanding 3x plus 5 whole squared, it will be 9x squared plus 25 plus 30x. Expanding this one, I'll get minus 5x squared minus 50x. Only it's not given that it's already greater than equal 0. We have to prove that. Now 9x squared minus 5x squared is 4x squared. 30x minus 50x is minus 20x plus 25. Whenever you have a quadratic and you want to prove that this quadratic is always going to be positive or whatever the value, always go for completing the square method. It will give you a definite answer. If specifically if you want to prove the quadratic term as always positive. So we know for a completing the square part, we have to take out 4 as common. Why? Because I need to make the coefficient of x squared 1. So whatever be the value of x squared here, you have to take out that as common. So taking out 4 out as common, remaining is x squared minus 5x plus 25 over 4. Now, we need to compare this middle part to 2a. So that is coefficient of x as 2a. After taking out number as common, what I am doing, comparing coefficient of x with 2a. So here 2a is equals to negative 5. So a is negative 5 over 2. Why did we do this? To find value of a. Next, we need to substitute a in x plus a whole squared. So a, since we have calculated as negative 5 over 2, so this will become x minus 5 over 2 whole squared. This will be x squared plus 25 over 4 minus 5x. Now compare this expansion of x plus a whole squared and original equation. So x squared is same. 25 over 4, 25 minus 5x is same. And 25 over 4 and 25 over 4 is same also. So you can clearly understand that this is nothing but x minus 5 over 2 whole squared. So in place of x squared minus 5x plus 25 over 4, I can write it as x minus 5 over 2 whole squared. So what you saw, that this can be written as like this. And here doesn't matter which value of x you will put, you will get always a positive answer. And if you're getting always a positive answer, that means definitely it's greater than equal 0. Question 14 says, here are two transformations. First, rotation 90 degrees clockwise about the origin. Second is reflection in the line y is equals to x. Use matrix multiplication to work out the single matrix which represents the combined transformation A followed by B. See, for what you have to do is, first we'll write down the original matrix. Let me see how can we do, and at the end we have to form the final transform matrix as well. See, to know how the particular point will behave in a matrix transformation, you first have to find the transform matrix, and that we are doing here. So we'll start with the point 1 comma 0. Here it's 0 comma 1 and this is 1 comma 0. We have 2 points. Whenever we draw the matrix, it's like x and this is y. So this coordinate 1 comma 0, this is my original matrix or original points which we have to transpose or transform ultimately. So 1 0, that means it's 1 0, and this 0 1 is written as 0 1. This is your original matrix. Now I have to rotate 90 degrees about origin. That means if I'm one by one, I need to see how each point will behave. Let me start with this point 1 comma 0. When I transform it 90 degrees clockwise, it will move like this, 90 degree clockwise. That means one quadrant. If it would be 180 degrees, so it will go like this. So that means 90 degrees it will move like this. 1 comma, when it will reach here, obviously this is y axis and here x is 0. So 0. And by single unit, whatever this radius, same it will be here. So that means it's by 1 unit. So 1 unit downward will be -1. So it will transform into 0 comma -1. So 1 0, that means this 1 0 will be transformed into 0 -1. So now I can write 0 -1. Next is 0 1. That means I'm talking about this one. So when I transpose it, it will go like this, 90 degrees. And if it's going 90 degrees, that means 0 comma 1 will become 1 comma 0 definitely. So 0 comma 1 is now 1 comma 0. So this is my transform matrix when it undergoes 90 degrees of rotation. Now we have to find the transformation separately. Second is reflection. So don't reflect this, okay? No, you have to reflect this, your original one. Every transformation will undergo whatever be the transformation, only your original matrix will undergo. So again I'll be saying this is 1 comma 0 and this is 0 comma 1. Reflection, that means it's like this. When you reflect, you draw a perpendicular line from the point to the mirror line. Why this is y equals x, that means this is your mirror line. And once it reaches here, you have to trace it back, because this is actually the law that you have studied in physics as well, that the distance between object and the mirror is always equals to distance between the mirror and the image. So in a plane mirror, similarly, this is y is equals to x, and if whatever distance is this, we have to trace it back in the same direction and we'll get 0 comma 1. That means 1 comma 0 will become 0 comma 1. This is for B. Similarly, if I see for 0 comma 1, so same, draw perpendicular from 0 comma 1 to the mirror line and now trace it backwards, you will get 1 comma 0. So they are basically mirror image of each other. So 0 comma 1 will become 1 comma 0. These are my two transform matrix, but we need a final transform matrix that will undergo these two transformation. So I need to multiply them together. Obviously you will think that A is happening first and B is happening second, so I'll multiply AB. No, it doesn't work like that. Whatever the transformation after it will be first. That means first A was there and then it undergoes B, but in multiplication it will be B and A. So we'll multiply B dash and A dash. Dash represents that it is finally transformed one. Or because they have already mentioned AB, so let me use AB itself. So B is 0, 0, 1, 1, 0 and A is 0, 1, -1, 0. For multiplication, we have to take row and column. So 0 multiplied by 0, that means first element multiplied by first element plus second element multiplied by the second element. So 0 times 0 is 0. So I'm writing 0 times 0 is 0 plus 1 times -1 is -1. Again same row and the next column. 0 times 1 is 0 plus 1 times 0 is 0. Next is this one, 1 0 and 0 -1. 1 times 0 is 0 and 0 times -1 is 0. Again 0 and this one. So 1 times 1 is 1 and 0 times 0 is 0. So final answer will be -1 0 0 1. This is our final transformed matrix. This is how we can solve it. Next is, here is a sketch of graph y is equals to cos x for x that is in between 0 to 360. You are given cos 360 is equals to 0.8090 and cos x is equals to -0.8090 for x which lies between 0 to 360. So we have to find what it says. Cos x is equals to 0. So we need to calculate the value and they have already mentioned 36. So x is then cos inverse negative 0.8090, because they have already mentioned that cos 36 degrees is negative 0.8090. Here we can use this one, and they have given graph. This is non-calculator. If it would be calculator, you can easily use cos inverse, but here for the reference they have given, see, if cos 36 degrees, that means 36 would be somewhere here, and it's like this, is 0.8090, that means the value of y is 0.8090. So negative value will be here, negative 0.8090. So if I go downwards like this point will be where I can get y as negative 0.8090. So you can clearly see that whatever be the distance from 0 to 36 degrees, same distance is from 180. That means we have to move 180 degrees towards left side, because this is a symmetrical one, if you see that. So it will be cos inverse is going to be then 180 minus 36 degrees, which is 144. So x is 144 degrees. Now we have to find the next value. So next value will be here. See this one. That means this is also, you can clearly read it, it's going like this. That means these points are on symmetry. So either side is 36, 36. So to calculate this angle, this will be 36. So next angle is going to be 180 plus 36, which is 216. So these are two values, that is 216. If you think that it's not very clear, you can repeat this video. I would suggest you, maybe first time it's not that clear and you just come to this conclusion that okay, I'm not getting this. If it's not clear, you can go back and repeat this video. You can easily understand what I have tried to clear it. Next is question number 16. Rationalize the denominator. We know rationalizing means that we have to remove the third number from the denominator. Removing third number from denominator is, how can we remove the third? In this case, when we have two thirds or one integer and one third number, we always multiply and divide with opposite sign. That means here it's plus a negative, so I'll multiply and divide by plus sign. So as it is, I have to write 21 minus 11 root 5 over 3 minus root 5. Then I need to divide and multiply, but with the positive sign. So here it will be 3 plus root 5 and 3 plus root 5. Now just need to multiply numerator and numerator, denominator and denominator. So 21 minus 11 root 5 times 3 plus root 5 over 3 minus root 5 times 3 plus root 5. 21 times 3, 63, plus 21 root 5 minus 33 root 5 minus 11 into 5 over, this will be a plus b, a minus b, that is a squared minus b squared. So this is a short way. Either you can multiply or expand just like how I did it here, or you can remember directly this one, a plus b times a minus b. A is 3 and b is root 5. So 63 minus 55 will give you 8, and 21 minus 33 will be minus 12 root 5. This is 9 minus 5, which is 4. So 8 minus 12 root 5 over 4. Taking out 4 out as common. So it's 2 minus 3 root 5 over 4. So cancelling it out, final answer will be 2 minus 3 root 5. So what is our answer? It's 2 minus 3 root 5. Question number 17. A, B and C are the points on the circumference of a circle. Center O. ECD is a tangent to the circle. If ECD is a tangent to the circle, that means here. Angle AOB is 2x plus 46. This angle is given. Angle OBC is 37 given. And angle ACD is 3x given. Now what we have to calculate? We have to calculate the value of x. So first thing is, at least I should know some relationship between anything and then I can solve it. But we have a triangle, so I can use the triangle sum property. That means sum of all the angles is equals to 180 degrees. That I can use. So for that, at least I should know all the angles of this triangle. So let me see how can we calculate that. Starting from, in triangles, either I can use this bigger triangle for angle sum property, or I can use this one as well. See, for this one, we already have one proper angle, because if I see the bigger one, there is no proper angle that I'm aware of. For this one, at least I have. So let me try to find other two angles, would be more simpler. Let me start with the first one, this one. Angle ACB is equals to half of angle AOB, because angle subtended by an arc at center is twice at circumference. So that means angle ACB will become half of 2x plus 46, which is x plus 23. So I can say this is x plus 23. This angle, and I can say this angle, whole of this angle, this is 33x. This whole angle is 3x because of alternate segment theorem. So I can say angle ACD is equals to angle CBA is equals to 3x. We can say alternate segment theorem. If you have little problem in alternate segment theorem, it's simple that there is a circle and it's a tangent. If I draw it like this, so this is angle and alternate segment. This is your segment, line segment here, right? So opposite to it is this angle. This is your alternate segment, the angle in your alternate segment. They both are equal. Similarly, this angle and the opposite segment is what? This segment. So this angle, they both are equal. This is alternate segment theorem. So according to that, they will be equal. So from here, I can say angle OBA. That means this angle I'm talking about. If this whole angle is 3x, so this particular angle will be 3x minus 37. So angle OBA is equals to 3x minus 37. We know if in this triangle, this is an isosceles triangle. Why? Because OB is equals to OA, as it's a radius. So in triangle OAB, OB is equals to OA is equals to radius. Hence, OAB is an isosceles triangle. An angle sum property will be, that means opposite angle will be equal. So I can say angle OBA is equals to angle BAO. So I can say this one will also be 3x minus 3. So this is also equals to 3x minus 37. 3x minus 37. Okay. Now, we have all the angles of this triangle. I can apply angle sum property. So in triangle OAB, I can say 3x minus 37 plus 3x minus 37 plus 2x plus 46 is equals to 180. This will give you 8x. Now this will be minus 28 is equals to 180. 8x is equals to 180 plus 28. 8x is equals to 208. So it will be 208 over 8. That will finally give you 26 as the answer. So we can say what's our answer? The value of its 26 degrees. Moving on to the next question. Question 18. ADEF is a trapezium. ABCD is a straight line. BCEF is a square of side root 6 centimeters. Show that AB is equals to root 2 centimeter. That means this line is root 2 centimeters. Obviously, we have to apply trigonometry because they have already mentioned that BCF is a square. So which clearly indicates if this is 90 degree, this is also 90. If this is 90, this is also 90. That means both the triangles are 90 degrees. So apply trigonometric ratios to get the answer. We have opposite because angle opposite to it is root 6. So this is opposite and we have to calculate adjacent. So tan 60 degrees I have to apply, which is opposite over adjacent. So it will go, I'll swap it, it will give me root 6 over tan 60 degrees. Root 6 over tan 60 degrees is equals to root 6 is over, this is root 3. We know root 6 can be written as root 3 times root 2. On cancelling out, I'll get root 2 as the answer. So final answer is root 2 and that we have shown it. Next is show that DE is 2 root 6. DE, that means this one. We know that if the height of this is root 6, that means this is also going to be root 6. So I can say in triangle ECD, this is root 6. So applying same, and what we have to calculate? Okay, this time we have to calculate ED. So if we want to calculate ED, this is hypotenuse that we have to calculate. So I need to apply sine now. So sine 30 degrees is equals to, so this will be opposite over hypotenuse. So opposite over hypotenuse. Sine 30 is half. This is root 6 and this is ED. So ED is finally 2 root 6 centimeters. 18C. Work out the perimeter of the trapezium ADEF and give your answer in this form. So perimeter, that means we have to calculate all the sides and add them up. For that, we should know this whole, this one, and this one. Let me see how many of the parts we already know. EF, I'm just solving right here. EF, because it's a square, is root 6 centimeter as its square. So all the sides are going to be equal. Similarly, BC is also going to be root 6. So now we know this one is root 6 and this one is root 6. ED we just calculated as 2 root 6. So 2 root 6 we already have. We have calculated AB as root 2. So we have root 2 as well. Now I can either apply trigonometry or I can apply Pythagoras theorem. I'll get the answer. So when I apply Pythagoras here in AFB, or we can apply trigonometry as well. So because we need to calculate hypotenuse, so I can apply sine here. So sine is opposite, that is root 6 over hypotenuse, that is AF. So AF is equals to root 6 over sine 60. Sine 60 is root 3 over 2. If you're not aware of every angle, then definitely you can go for Pythagoras theorem. So root 3 over 2 is root 6 root 3 over 2. So that is 2 root 2. That will be our answer. This is 2 root 2. Only this one is remaining. So I can apply what we need. We already have this root 6. We can apply any. I'm just applying tan theta. So in triangle EDC, I'm applying tan theta. Only I'm this one. If it's confusing you, you can clearly understand what I'm saying is I'm applying in this triangle because I want to calculate DC, that is adjacent. So I have hypotenuse, I have opposite, so I can use tan theta. I can use actually cos theta as well. But let me see tan theta. So tan 30 is opposite, which is root 6, over adjacent, which is CD. So CD will be root 6 over tan 30, and root 6 tan 30 is 1 over root 3. So final answer is root 18. Root 18 can be simplified as 3 root 2. So final perimeter is going to be add of all these. That means root 6 plus 2 root 6 plus 3 root 2 plus root 6 plus root 2 plus 2 root 2. So that means I need to add all the root 2's and root 6. So root 6 plus 2 root 6 plus root 6. Answer is 4 root 6. 3 root 2 plus root 2 plus 2 root 2 is plus 6 root 2. So this is how we can write our final answer in this format. Now moving on to the next one. Fx is equals to x minus 3 over 2x. Solve f of x plus 1 minus f of 2x is equals to 0.5. See, we know f of x plus 1, that means I need to substitute the value of x that. If suppose it's written as f2, that means we have to put x equals 2. So if it's x plus 1, I need to replace x with x plus 1. That's all I have to do it here. So wherever here I can see x, I need to replace it with x plus 1. So if fx is equals to x minus 3 over 2x, then f of x plus 1, that means replacing all x with x plus 1. So this will be x plus 1 minus 3, right? In place of x, I wrote x plus 1. Similarly, here in place of x, I'll write x plus 1. Similarly, I can calculate f of 2x. That means everywhere where I can see x, I need to replace it with 2x. So x will become 2x minus 3. And similarly here x, so 2 is already outside and this x is 2x. Let me simplify this one. It will give you x plus 1 minus 3 over 2x plus 2. So final answer is x minus 2 over 2x plus 2. For this one, if I simplify 2x minus 3, and this will be 4x. It says now I need to substitute here this value. So f of x plus 1 is x minus 2 over 2x plus 2. And f of 2x is minus 2x minus 3 over 4x is equals to 0.5 or half. It means the same. Now taking LCM. LCM is 2x plus 2 times 4x. So this is your LCM. So to make it same, you'll multiply it with 4x and multiply this with 4x as well. Multiply this with 2x plus 2 and multiply this with 2x plus 2 as well. So now your final will be 4x times x minus 2 minus and 2x minus 3 multiplied by 2x plus 2. This is equals to half. Let me simplify it further. So 4x times x is 4x squared. 4x minus 2 is minus 8x. Minus 2x times 2x is 4x squared. 2x times 2x is plus 4x. Minus 3 times 2x is minus 6x. And minus 3 times 2 is minus 6. Over 4x times 2x is 8x squared. And 4x times 2 is plus 8x is equals to half. This will be 4x squared minus 8x minus, simplifying inside, you will get 4x squared minus 2x minus 6 over 8x squared plus 8x is equals to half. Let me simplify it. 4x squared minus 8x minus 4x squared plus 2x plus 6 over 8x squared plus 8x is equals to half. Now taking out 2 out as common. So let me just simplify first. So 4x minus 4x 0. Minus 8x plus 2x will give you minus 6x plus 6 over 8x squared plus 8x is equals to half. Bringing out 2 out as common. This will be 2 times minus 3x plus 3 over 2 times 4x squared plus 4x. Now I can cancel that out 2 and 2. So this will be minus 3x plus 3 over 4x squared plus 4x is equals to half. On cross multiplying, this will be 2 times, because 2 will go up there and this will go up there. 2 times minus 3x plus 3 is equals to 4x squared plus 4x. This will be minus 6x plus 6 is equals to 4x squared plus 4x. So final it will be 4x squared. Bring 6 here, it will be plus 10x and minus 6 equals 0. This is a quadratic equation that we have to solve. We can do it by factorization method. We have to find two numbers. The product should be equals to 4 into 6, that is negative 24, and sum should be equals to 10. So those two numbers are 12 and negative 2. So splitting the middle term, 4x squared plus 12x minus 2x minus 6. Here taking out 4x as common, it will be x plus 3. Here taking negative 2 out as common, x plus 3. Factors are 4x minus 2 times x plus 3 equals 0. From here 4x minus 2 equals 0. So x is equals to half and x plus 3 is equals to 0. It's negative 3. So two values of x are half and negative 3. This was basically the last question. We have done all the questions in this paper. If you find any difficulty, you can go back and see the videos, and still if you find any difficulty, you can just email me for any question. If you have any doubt in any segment of this video, you can just email me. I can even share you one more video just for free, okay? And as well as I can share you the written format as well. So that's it for today. I'm just running a GCSE batch classes for further maths triple science. If you want to enroll for a demo, just email us at exactacademy@gmail.com. And throughout the year, if you need classes for any subject from year 1 to 13, just email us at exactacademy@gmail.com. So that's it for today. Thank you. Have a great day.